Practice problem 8.11 says draw two equivalent resonance structures for the formate ion, HCO2-. So the first thing we want to do, like we always do, is we count up our number of valence electrons. Okay, so we have hydrogen, we have a carbon, we have two oxygen, and we have a negative charge. And so hydrogen has 1 valence, carbon has 4 valence, oxygen has 2 times 6 valence electrons, and we have a plus 1 for the minus charge, which gives us a total of 18 electrons. Alright, so the first thing we know is we know carbon is going to go in the center. Okay, carbon has a hydrogen bound to it, and then it has 2 oxygens bound, 1 and 2. Okay, so that's 6 of our electrons right off the bat. So we have 12 left. Okay, we notice that carbon only has 3 bonds to it, okay, which means it has a total of 6 electrons. It needs 2 more. Oxygen actually could form a double bond, and so if we draw in a double bond between one of the carbons, that's another 2 electrons, which leaves us 10. So at this point, carbon has its octet, hydrogen's fine. How about the oxygens? Well, we have 10 electrons left, so let's give this oxygen an octet, so we have to add 4 to it. And if we give 6 to this oxygen, we're also going to give it a full octet. So we use up all 10 electrons, and carbon and oxygen both have their octet of electrons, and hydrogen is sharing its 1. So we said that there are 2 equivalent resonance structures. Well, the only difference is that we could draw this double bond on the other oxygen as well. And so basically we can just write that we have carbon, we have a hydrogen, we have oxygen, 2, 3, 4, 5, 6 electrons, and then we could have a double bond on this oxygen as well. Okay, 2 equivalent resonance structures for the HCO2- ion. Alright, the last thing we need to do on both of these structures is we're just going to put in our brackets and show that it's a negative charge on that. Okay, so we always have to put the charge in the brackets.